p110 and starting our unit on reactions. So let's make sure that we are familiar with the parts of a reaction. So here's a full chemical reaction where it says 2H2G plus O2G arrow 2H2OG plus energy. So let's make sure that we understand what all of these things represent. So the first thing is we have a chemical formula here. So this is the chemical formula for the substance hydrogen H2. Now, to the right of the hydrogen, there is a little lowercase g in parentheses, and that means it is a phase. That tells us the phase of this substance hydrogen. So when you see a lowercase letter in parentheses to the right of the chemical formula, it's indicating the phase. So since this one has a G, it means that the H2, it exists as a gas. Sometimes you will see a lowercase l, which would mean it is in the liquid phase. And if it is an S, it means that the sample or the substance is in the solid phase. We also have our phase AQ, which means it is aqueous. So we will see these all the time. Now, when we take a look, there is to the right, it says H2G, and then there is a plus sign. The plus sign, it separates the substances on the same side of the arrow, just like a comma. So this plus sign means that H2 is a different substance than O2. So H2 is one substance, O2 is a different substance. Now, the other thing that you will notice is that H2 is the chemical formula, but out in front of H2, there is this number, this big 2. Those large numbers that we see out in front of a chemical formula, like the 2 in front of the H2, we refer to these as coefficients. So a number out in front of the formula. It gives us how many units of each substance is used or formed during a reaction. And these coefficient numbers represent the relative number of moles. Now, if you take a look, O2 does not have a number written out in front of it like the H2 does. So if there is no written coefficient, it is understood to equal 1 mole. So just like we don't write in subscripts of 1, we won't write in coefficients of 1. The purpose of these coefficients, they are used to balance the reaction to maintain the law of conservation. So the type and number of hydrogens that we have on the right-hand side of the arrow has to be the same as the left-hand side. So the type and number of atoms on the left side of the reaction must equal the number of atoms on the right side of the reaction. So if we have 4 hydrogens on the left, we can only have 4 on the right. We can't have 4 hydrogens on the left and 8 hydrogens on the right. So our total hydrogen count has to be exactly the same on both sides of the arrow. Now notice, we do have an arrow. It separates. So there's the left-hand side of the arrow versus the right-hand side of the arrow. The purpose of the arrow, it separates the reactants from the products. So it's a division point. So the reactants, what we see on the left-hand side of the arrow, we refer to these as the reactants. They are the original starting substances. This is like the ingredients you might pull out of the cupboards in the refrigerator and what you put into your mixing bowl. These are the ingredients that we start with, and we put them in our beaker or test tube. They're always listed on the left-hand side of the arrow. These are the ingredients that are consumed or react during the reaction. So these are consumed to make the product. Right? So if you're making cookies that require butter, you put butter into your mixing bowl, but at the end of the baking process and making cookies, you don't expect to take a stick of butter out of the oven. No, the butter has been consumed to make those cookies. Well, in a chemical reaction, how are the reactants consumed, or another word might be used? So I might write the word used here. Well, they are consumed because it is their bonds that break. So the bonds between the hydrogen break, the bonds between the oxygen break. So on the reactant side, this is where those bonds break and the atoms rearrange. And then when we go to the right-hand side of the arrow, the right-hand side of the arrow is the products. This is the ending produced substances. What is made in the reaction? Okay, so this is what is made. And these are always shown to the right of the arrow. In any of the chemical formulas that we see on the right-hand side, there are some new bonds that are formed. So this is where we have new bonds are formed. So this is a different substance. And because there's a new bond, there's a new atom composition and ratio in these formulas, these substances, they end up with a new formula and name, which means that they have different or new properties compared to what we started with. So they have a new name, or new formula, new name, and new properties. And then also what we tend to see in many reactions is the idea of energy. Reactions can only happen if energy is involved. It's a driving force. So we will see the term energy, maybe a form of energy like heat or light, or we could see the number of joules of energy. So we could see this, instead of just the general term energy, we could see a form of energy, like we could see the word heat, or we could see a number of joules. I don't know what the number of joules here is specifically, so I'll just write down. So maybe it's 2,100 joules of energy. And we'll learn whether the energy is absorbed or released.